In the boundless depths of the cosmos, humanity has always gazed upward with longing eyes, searching for worlds beyond our own. Among the countless exoplanets discovered, one name ignites both excitement and unease: Proxima B, orbiting the star Proxima Centauri. Just over 4 light-years away, it stands as the closest potentially habitable planet beyond Earth. For some, it represents hope, a second cradle for humanity, a world waiting to be shaped into a home. But for many scientists, the very thought of attempting to terraform Proxima B awakens deep fears. Its star is unstable, its atmosphere unknown, and its potential dangers vast. To dream of reshaping this alien world is to step into the unknown, where promise and peril intertwine. Tonight, we will explore not only the possibilities of making Proxima B habitable, but also the haunting reasons why scientists hesitate. The deeper we look, the more chilling the answers become. So, let us begin. When astronomers announced the discovery of Proxima B in 2016, the world was captivated. Here was a planet orbiting the closest star to our Sun, a neighbor just within cosmic reach. Unlike the distant, gas giants or scorched wastelands we had grown accustomed to finding, Proxima B seemed almost too perfect. It resided in the so-called habitable zone, the delicate band of distance where liquid water could, in theory, exist on a planet's surface. This instantly transformed it into a symbol of hope, a potential sanctuary for humanity's future. The planet is thought to be roughly 1.3 times the mass of Earth, suggesting a rocky surface rather than a gaseous envelope. If true, this would mean mountains, valleys, and perhaps vast stretches of terrain not unlike the continents we walk upon. Even more intriguing, the gravitational pull of Proxima B would be similar enough to Earth's that a human visitor could, in principle, stand upon it without being crushed or floating away. To the scientific imagination, these details made it a world of possibilities. Science fiction has long painted vivid pictures of humankind spreading among the stars, and Proxima B was heralded as the first real candidate to make those stories come alive. Headlines spoke of Earth's twin and a second home. Some speculated about space missions that might, within a few decades, send robotic probes to deliver humanity's first close-up look at this alien landscape. For the public, Proxima B was not just another planet. It was a beacon, an answer to the existential question of whether we are destined to remain confined to Earth, or if our species might one day claim the stars. Yet beneath this wave of excitement, scientists themselves grew cautious. For every detail that suggested habitability, others hinted at danger. The reality of Proxima B was beginning to look far harsher than the optimistic headlines. The more astronomers investigated, the more they realized that making this world habitable might require far more than just hope. It might demand rewriting the very rules of survival. At the heart of Proxima B's uncertainty lies its star, Proxima Centauri. Unlike our stable, yellow sun, Proxima Centauri is a red dwarf, the smallest and most common type of star in the galaxy. Red dwarfs burn dimly, producing only a fraction of the light we receive on Earth. On the surface of Proxima B, the skies would never glow with the bright, golden warmth we know. Instead, daylight would appear dim and reddish, casting a perpetual twilight across the land. To human eyes, this would already feel alien, as though we were standing beneath a fading sunset that never ends. But the greater danger comes not from the dimness of the light, but from its volatility. Red dwarfs are notorious for their violent stellar flares, bursts of radiation and charged particles that erupt without warning. Proxima Centauri is no exception. In fact, astronomers have observed flares from this star that are hundreds of times more powerful than anything our Sun produces. These flares unleash torrents of ultraviolet and X-ray radiation, enough to strip atmospheres from planets and scorch any surface unlucky enough to be unshielded. For Proxima B, orbiting at a distance far closer than Earth sits from the Sun, this is a devastating problem. To remain in the habitable zone of such a cool star, the planet must cling tightly to its parent, circling in just 11 days. This proximity means it is locked in a cosmic dance, constantly exposed to the storms of radiation that batter its skies. Even if Proxima B once possessed an atmosphere like Earth's, the relentless blasts of solar wind may have torn it away long ago. Scientists fear that any attempt to terraform or colonize Proxima B would be undermined by this stellar violence. Without a thick, protective atmosphere, or perhaps even a magnetic field stronger than Earth's, any fragile ecosystem we might build could be shredded by radiation before it ever had a chance to thrive. Proxima B tempts us with its closeness, but its sun may be the very reason it remains barren and hostile. Another invisible challenge lies in the way Proxima B moves around its star. Given its short orbital period and proximity, scientists believe the planet is tidally locked, much like our Moon is to Earth. If this is true, one hemisphere of Proxima B faces eternal daylight, while the other remains forever in darkness. The consequences of this arrangement are extreme. On the star-facing side, temperatures could soar to levels that vaporize water, leaving the land scorched and barren. On the far side, shielded from all light, the surface would plunge into frigid darkness, colder than the iciest reaches of Earth's poles. Between these two extremes lies a narrow twilight zone. A band of permanent sunset where conditions might, just barely, allow liquid water to exist. But living in such a world would be fraught with difficulty. Winds would howl endlessly across the surface as the heat of the day side drives air toward the frozen night. Storms could be violent and constant, shaping a planet where stability is nearly impossible. For settlers, this would mean choosing between unbearable radiation and searing heat, or endless darkness and cold. Survival might only be possible along the razor-thin line of twilight, an area so limited that humanity could find itself confined to a narrow strip of land, struggling for resources in a fragile equilibrium. Terraforming such a world would pose immense challenges. Balancing temperatures, generating artificial day-night cycles, and maintaining atmospheric circulation would require technological feats beyond anything humanity has yet achieved. Scientists worry that even if we manage to land on Proxima B, the planet's very nature would trap us in a hostile environment, one that no amount of optimism could transform into a true second Earth. If Proxima B is to host life, or to be transformed into a future home for humanity, it would need one essential ingredient: a stable atmosphere. On Earth, our atmosphere does far more than provide the oxygen we breathe. It shields us from harmful radiation, regulates temperature, and protects the surface from meteors. Without it, life as we know it would never have emerged. But for Proxima B, the question of atmosphere is a haunting one. Astronomers suspect that the constant bombardment of stellar winds from Proxima Centauri may have eroded any primordial atmosphere billions of years ago. Unlike Earth, which benefits from a strong magnetic field generated by its molten core, Proxima B may lack such a defense. If that is the case, then any attempt to create an atmosphere would be like building a sandcastle in the path of the tide, constantly washed away by the star's fury. Even if some atmosphere remains, it is unlikely to resemble the delicate balance we enjoy on Earth. A thick atmosphere rich in carbon dioxide could lead to a runaway greenhouse effect, making the world unbearably hot. Conversely, a thin and unstable one might fail to hold enough warmth, plunging the surface into icy wastelands. Either extreme would make sustaining human life nearly impossible without massive intervention. Terraforming would require transporting vast amounts of gases or creating artificial magnetic shields in orbit, projects so colossal they make our current space engineering look primitive. Scientists fear that the energy and resources required might outweigh the benefits, turning Proxima B into an endless sinkhole for human ambition. In this sense, Proxima B represents not just an astronomical puzzle, but a reminder that our Earth's protective shield is far rarer and far more fragile than we often appreciate. Even if humanity somehow managed to solve the atmosphere problem, one danger would remain unavoidable: radiation. On Earth, our ozone layer and magnetic field filter out most harmful cosmic rays and ultraviolet light. But Proxima B orbits so close to its parent star that radiation levels there would be overwhelming. Observations suggest that the planet receives hundreds of times more X-rays than Earth does. For any unprotected organism, this would be lethal. Radiation doesn't just harm surface life, it destroys the very chemistry that makes life possible. DNA, the blueprint of all living beings, unravels under intense radiation. On Proxima B, fragile microbial colonies would likely be sterilized before they could gain a foothold. For humans, the risks are even greater. Constant exposure would increase cancer rates, damage organs, and slowly erode health in ways we can scarcely imagine. One might imagine building underground habitats, shielding colonists beneath layers of rock. While this could reduce radiation exposure, it would also sever humanity from the surface, forcing colonists to live like moles in a world that offers no open sky. Alternatively, giant orbital shields might be constructed to block the flares, but such megastructures belong more to science fiction than current engineering. This is why many scientists hesitate when asked about Proxima B's potential. Even if it looks promising on paper, the invisible storm of radiation could render the planet permanently uninhabitable. It's a haunting thought. The closest Earth-like world may be a death trap, its beauty hiding a lethal reality. Water is often described as the lifeblood of habitability. On Earth, it shapes landscapes, regulates climate, and sustains every living cell. When scientists search for habitable worlds, water is their first priority. Proxima B, tantalizingly, may lie in a position where liquid water could exist. But that possibility is filled with uncertainty. If the planet has no atmosphere, then water could never persist as a liquid. It would either boil away into space or freeze into permanent ice. Even if some water remains locked underground or trapped as ice on the dark side, accessing it would be a monumental challenge. Colonists would have to drill, mine, and transport resources in conditions far harsher than any desert on Earth. On the day side, any exposed water could form boiling oceans under the glare of Proxima Centauri's radiation, constantly evaporating and condensing into unstable cycles. On the night side, vast glacier may stretch endlessly across the frozen plains, inaccessible to settlers who would be unable to endure the crushing cold. Terraforming efforts might require importing water from icy comets or moons. Again, an endeavor of staggering difficulty. Without water, there is no agriculture, no ecosystem, and no long-term survival. Scientists fear that Proxima B could easily become a barren experiment, a place where humanity pours effort and technology only to find a dry, lifeless world incapable of nurturing even the simplest life forms. One of Earth's greatest defenses is invisible, our magnetic field. Generated deep within our molten core, this shield deflects the solar wind, protecting our atmosphere and surface from being stripped bare by charged particles. Without it, Earth might resemble Mars, cold, dry, and barren. For Proxima B, the mystery of whether it possesses such a shield is a critical question. The planet's close orbit around its volatile star exposes it to constant streams of charged particles. If Proxima B lacks a strong magnetic field, its atmosphere would be eroded steadily over billions of years. Even if it started with Earth-like conditions, the relentless bombardment would leave little more than a lifeless husk. Some models suggest that tidal locking, where one side always faces the star, might reduce the core's ability to churn and generate magnetism. If true, the planet would be essentially naked in the face of stellar fury. Scientists fear that even advanced human engineering may not overcome this problem. Building a magnetic shield for an entire world is not a trivial task. It would require constructing enormous orbital stations capable of generating fields strong enough to deflect the solar wind. This would demand more power than our entire planet currently produces. Without such protection, Proxima B's skies would remain hostile forever, ensuring that any attempt to create a habitable world would be met with the constant erasure of progress. It is a sobering thought. Proxima B may not just be inhospitable, it may be actively resistant to ever being made safe. Another unknown about Proxima B lies beneath its surface. On Earth, geology is the engine of habitability. Volcanic eruptions release gases that replenish the atmosphere, plate tectonics regulate carbon dioxide, and geothermal energy provides warmth even in frozen environments. Without these cycles, Earth's climate might swing widely between extremes, unable to sustain complex life. Proxima B's internal dynamics remain a mystery. If it has an active molten core, then it might produce both a magnetic field and geothermal activity, two factors that improve its chances of habitability. But if its interior has cooled and solidified, the planet could be geologically dead. Without volcanic outgassing, an atmosphere could never be replenished. Without tectonic movement, climate stability would be impossible. Colonists hoping to terraform the planet would depend heavily on geology. If the crust is too thick or unyielding, mining resources would be nearly impossible. If tectonic activity is violent, earthquakes and volcanic eruptions might make settlement dangerous. The planet could be too quiet or too unstable. Either extreme presents a nightmare for long-term survival. Scientists cannot yet peer beneath the rocky shell of Proxima B, but the uncertainty itself fuels concern. If we gamble on this world, we might find ourselves trapped on a planet that offers no foundation for stability, a surface that looks promising but hides a lifeless, unforgiving core. Even if humanity somehow overcame the radiation, atmosphere, and geology of Proxima B, there is one challenge we often overlook: the human mind. Life on such a world would not resemble the open skies and dynamic cycles of Earth. Instead, it would be defined by alien skies, eternal twilight, and a sense of confinement that no technology could erase. On a tidally locked planet, colonists might never see a sunrise or sunset. On the day side, the sky would glow with a perpetual, dim red light. On the night side, only the faint glimmer of distant stars would break the endless darkness. Imagine living in a place where time itself feels frozen, where there is no day to begin and no night to end. For human psychology, which depends on rhythms and cycles, such conditions could be devastating. Studies on Earth show how lack of sunlight can lead to depression, disorientation, and reduced cognitive function. Now imagine generations born under alien skies, never experiencing the blue vault of Earth, the warmth of the sun, or the comfort of familiar cycles. Artificial lighting could simulate these effects, but would it ever truly replace them? Scientists worry that colonizing Proxima B could lead to a slow unraveling of the human spirit. A world may be technically habitable, but psychologically unbearable. In the quest for survival, humanity may discover that its greatest challenge is not nature, but itself. The dream of Proxima B often rests on the idea of terraforming, reshaping a hostile world into something resembling Earth. In theory, this means building an atmosphere, regulating temperatures, and introducing water and life. But in practice, the scale of this task borders on the unimaginable. To create a breathable atmosphere, we would need to release trillions of tons of gases, nitrogen, oxygen, and carbon dioxide, in just the right balance. On Earth, this balance took billions of years of biological and geological processes to achieve. Replicating it artificially on Proxima B would demand technology we do not yet possess. Even if we could import the raw materials, we would face the constant challenge of stellar flares stripping them away. Terraforming might become a never-ending battle between human ambition and cosmic violence. Then there is the question of heat. On the star-facing side, constant radiation would overheat the land. On the night side, cold would freeze any atmosphere solid. To terraform effectively, we would need to stabilize global temperatures, perhaps by constructing orbital mirrors, shields, or even artificial suns to distribute light. Each of these projects would require energy on a scale greater than anything humanity has ever attempted. Scientists fear that investing in such a gamble could lead to disappointment. What if, after centuries of effort, Proxima B still resists transformation? What if our best attempts leave it forever unstable, a half-altered wasteland that can never truly sustain us? The fear is not only that Proxima B may be hostile, but that it may remain hostile, no matter what we do. For all that we think we know about Proxima B, the truth is that most of its nature remains a mystery. Telescopes can only tell us so much. We know its approximate size, mass, and distance from its star. But everything else, its atmosphere, surface composition, water content, and climate, is speculation. In this sense, Proxima B is not just a planet, it is a question mark written across the sky. Scientists fear that the unknowns themselves may hold the greatest dangers. Perhaps Proxima B is not solid at all, but a barren rock with no resources worth mining. Perhaps its surface is covered in toxic compounds, hostile to both human lungs and machines. Perhaps the very chemistry of the world is incompatible with the molecules that make life possible. And then there are more subtle unknowns. What if Proxima B harbors microbial life, evolved under conditions we cannot predict? Far from being harmless, such life could pose biohazards unlike anything we have faced. Our immune systems, built on Earth's ecosystem, would be defenseless against alien pathogens. Even if microscopic, such organisms could devastate human colonists. The fear here is not born of pessimism, but of realism. To treat Proxima B as a blank slate for humanity's dreams is to underestimate the strangeness of the cosmos. We project our hopes onto its surface, but the truth is that Proxima B could be nothing like Earth. The more we learn, the more we realize how dangerous it is to assume otherwise. Even if Proxima B were a perfect candidate for colonization, one final obstacle looms above all others: distance. At over 4 light-years away, Proxima B is the closest known exoplanet to Earth. Yet in human terms, it is unimaginably far. With our current rocket technology, it would take tens of thousands of years to reach it. Projects like Breakthrough Starshot and Vision tiny probes propelled by powerful lasers, capable of making the journey in just a few decades. But these are unmanned craft, carrying only cameras and sensors. For human travelers, the challenges multiply: food, water, radiation shielding, propulsion, and above all, time. Even with breakthroughs in propulsion, the journey could last centuries. Colonists would need to survive in self-sustaining ships for generations before ever setting foot on Proxima B. Distance also means isolation. A signal from Earth takes over 4 years to reach Proxima Centauri. A conversation with home would take nearly a decade for a question and answer. For settlers, this would mean permanent severance from Earth. They would not be colonists so much as exiles, cut off from everything familiar. Scientists fear that in the pursuit of Proxima B, humanity may underestimate this barrier. The planet may be near in astronomical terms, but for us, it is as distant as the stars themselves. To chase it too early may mean losing ourselves in the void, long before we ever arrive. If humanity ever attempted to settle on Proxima B, one of the first questions would be, how do we power our civilization there? On Earth, we rely on abundant sunlight, fossil fuels, nuclear energy, and wind and water systems shaped by our planet's climate. On Proxima B, none of these can be taken for granted. The dim, red light of Proxima Centauri would provide far less solar energy than Earth receives. Solar panels would produce only a fraction of their normal output. Fossil fuels, if they exist at all, would require millions of years of planetary biology to create, something Proxima B may never have had. Wind power would depend on unpredictable weather patterns that could be violent, unstable, or absent altogether. Nuclear reactors might serve as a fallback, but transporting uranium or other fuels across interstellar distances would be enormously expensive. Mining local resources could be impossible if the geology proves barren or toxic. Even fusion, the holy grail of energy, would require technological breakthroughs not yet realized. Scientists worry that any colony on Proxima B would face constant energy shortages, limiting growth and forcing settlers into a fragile balance. The fear is that survival would demand such enormous energy expenditure that colonization would collapse under its own weight. Rather than a second Earth, Proxima B could become a desperate outpost, forever on the brink of failure. Beyond science and engineering, Proxima B raises questions of ethics. If the planet harbors even the faintest traces of microbial life, do we have the right to alter it? On Earth, life has shaped the planet for billions of years. To erase or overwhelm native organisms with Earth-based biology would be, in a sense, an act of cosmic colonization. The ethical debate grows even more complicated when considering humanity's track record. On our own planet, colonization often led to exploitation, extinction, and irreversible change. If we repeat those patterns on an alien world, the consequences could be magnified beyond comprehension. Imagine extinguishing the only form of life outside Earth we have ever discovered, simply to make room for ourselves. Some scientists argue that the search for habitable worlds should not be about conquest, but about stewardship. They fear that rushing to terraform Proxima B could mean destroying an irreplaceable window into biology beyond Earth. If alien life exists, it may hold secrets about evolution, resilience, and survival that could teach us more than colonization ever could. Thus, Proxima B does not simply challenge our technology. It challenges our morality. In the pursuit of survival, we may confront questions about what it truly means to share the cosmos and whether humanity is ready for that responsibility. Perhaps the greatest fear scientists hold about Proxima B is not what it is, but what it reflects back at us. In our eagerness to find a new home, we risk ignoring the fragility of the one we already have. Earth provides us with everything Proxima B lacks: a breathable atmosphere, liquid oceans, fertile land, and a protective magnetic field. And yet, we strain these gifts through pollution, deforestation, and climate change. Some scientists argue that the obsession with Proxima B reveals a dangerous mindset, that humanity can abandon Earth and simply start again somewhere else. But Proxima B shows us that such dreams may be illusions. If even our closest neighboring world is hostile to life, then habitable planets may be far rarer than we hope. The lesson is stark: we cannot count on finding another Earth. In this light, Proxima B is not just a scientific curiosity, but a warning. The difficulties of making it habitable underscore how extraordinary our own planet is. Rather than dreaming of escape, perhaps our greatest challenge is to care for the home we already possess. And yet, the fear remains. If we fail to protect Earth, and Proxima B cannot save us, where then will humanity turn? Even if we solve Proxima B's atmosphere, radiation, and energy challenges, there remains a fundamental truth: human biology is adapted to Earth. Our bodies evolved under a specific set of conditions: gravity, temperature, atmosphere, and day-night cycles that shaped every aspect of our physiology. On Proxima B, each of these would be altered, and the consequences could be profound. The slightly higher gravity, while survivable, could strain muscles, bones, and the cardiovascular system. Over generations, colonists might develop shorter, stockier builds, with bodies warped to endure constant weight. Meanwhile, the absence of regular day-night cycles would disrupt circadian rhythms. Sleep, hormone production, and even mental health could collapse without careful artificial regulation. Radiation would continue to attack DNA, leading to genetic mutations passed from parent to child. After a few generations, Proxima B humans might no longer resemble Earth humans at all. They might adapt biologically to their alien environment, becoming stronger in some ways, weaker in others, but undeniably different. This possibility haunts scientists. Colonizing Proxima B could mean splitting humanity into separate branches of evolution. In the attempt to save ourselves, we might create a future where those who leave Earth are no longer truly us. Proxima B, instead of a second Earth, could become the birthplace of a second humanity, alien to its own origins. Distance from Earth is not only a technological challenge, it is a psychological and cultural one. A colony on Proxima B would be more than 4 years away from even the simplest communication. Messages would travel at the speed of light, but for colonists, every exchange with Earth would be delayed, distorted, and incomplete. Generations of settlers would grow up knowing they would never return to Earth, never see its blue oceans or green forests, never feel connected to the planet of their ancestors. Over centuries, a cultural divide would widen. Traditions, languages, and values might drift until colonists no longer identified with Earth at all. they would become an isolated civilization shaped not by human history, but by the brutal realities of their alien world. Scientists fear this cultural fracture. Humanity has always been divided, even when confined to one planet. What would happen when distance made cooperation impossible? Would Proxima B settlers evolve into an independent society, cut off from Earth, perhaps even hostile to it? Colonization could mark not the expansion of humanity, but its fragmentation, our species splintering across the stars, never to reunite. The dream of a galactic future often imagines unity and exploration. But Proxima B could be the beginning of something darker. The permanent isolation of human groups, each locked in their own alien cages. Behind every discussion of Proxima B lies a haunting possibility. What if we try and fail? Colonization would demand immense resources, the cooperation of nations, and centuries of effort. But if the project collapses, if the colony fails, what then? Imagine a generation ship carrying thousands of souls, launched across interstellar space with no return. After decades or centuries, they arrive at Proxima B only to discover a world far more hostile than expected. Crops cannot grow, habitats fail, radiation sickness spreads. A once hopeful mission becomes a slow descent into despair, with no hope of rescue. The colonists would die on an alien world, their sacrifice a grim monument to human overreach. The fear is not only of loss, but of consequence. A failed colony could scar humanity's ambitions for centuries, discouraging future exploration and wasting resources that might have safeguarded Earth itself. Worse still, a doomed settlement might transmit desperate signals back to Earth, pleas for help that can never be answered. The psychological weight of such a failure could cast a shadow across our species, reminding us not of our courage, but of our limits. In this sense, Proxima B is both a promise and a threat. It tempts us with possibility, but warns us that the price of failure could be the most haunting story humanity has ever told. When the discovery of Proxima B was first announced, headlines proclaimed it to be Earth's twin. But scientists quickly began to push back against that label. They warned that the word habitable zone is misleading. It does not mean a planet is habitable, only that it lies at a distance from its star where liquid water could exist. Everything else, the atmosphere, radiation levels, geology, and chemistry, could still make it utterly hostile to life. This distinction is crucial. For the public, the term habitable zone sparks images of oceans, forests, and skies like our own. In reality, Proxima B might resemble nothing more than a scorched wasteland or a frozen desert. Scientists fear that overselling Proxima B as Earth-like raises false hopes and feeds dangerous illusions about our future among the stars. If humanity begins to view planets like Proxima B as easy escapes, we risk ignoring the hard truth: habitable worlds may be vanishingly rare. The more we study exoplanets, the more it seems Earth is not typical, but exceptional. In this light, Proxima B becomes less a paradise and more a mirage, a shimmering illusion of salvation that vanishes the closer we look. Colonizing Proxima B would require technologies we cannot yet build. Faster-than-light travel remains the stuff of theory. Self-sustaining generation ships are only ideas on paper. Terraforming tools capable of transforming an entire world exist only in imagination. Yet time presses forward. Climate change, overpopulation, and dwindling resources on Earth make some wonder if we must rush toward new worlds before it is too late. This tension creates fear among scientists. If we pursue Proxima B too soon, with technology unready, we may doom any attempt to failure. If we wait too long, Earth itself may decline beyond repair, leaving us no choice but desperation. The balance between readiness and urgency is razor thin. Furthermore, time is not on Proxima B's side. Red dwarf stars live for trillions of years, but their early centuries are violent. Proxima Centauri may have already sterilized its planet with radiation long before Earth had even formed. By the time we are ready, Proxima B may be nothing more than a burnt-out husk, survivable only in domes, never transformed into a true home. Thus, scientists fear not only Proxima B's conditions, but also the timing of humanity's ambitions. Too early, and we perish. Too late, and we arrive at a world long dead. Perhaps the most profound fear of all is psychological, the fear that Proxima B offers us false hope. Humanity has always dreamed of the stars, imagining them as escape routes from the fragility of Earth. Proxima B, being so close, embodies that dream more than any other world. It whispers to us, here is another chance. Here is a future beyond Earth. But scientists warn that this dream may be dangerous. If we cling to the idea of Proxima B as salvation, we may neglect the urgent work of saving Earth. Believing that another Earth awaits could weaken our resolve to confront climate change, protect ecosystems, and build sustainable societies here at home. The danger is not only scientific, but moral. We may allow fantasy to blind us to reality. In this sense, Proxima B becomes a symbol of humanity's dilemma. It is close enough to tempt us, but hostile enough to betray us. It may never be our refuge, yet it draws our gaze away from the only refuge we truly have, Earth. The fear is not just that Proxima B is uninhabitable. It is that in chasing it, we might abandon the world we already inhabit, only to discover too late that the stars cannot save us. At just over 4 light-years away, Proxima B is often described as being close. In cosmic terms, that is true, it is the nearest exoplanet to Earth. But proximity in astronomy is deceptive. 4 light-years translates to nearly 40 trillion kilometers. No spacecraft humanity has ever built comes close to traveling such a distance within a single lifetime. The Voyager probes, for example, launched in the 1970s, have traveled farther than any human-made objects in history. Yet, even at their incredible speeds, it would take them over 70,000 years to reach Proxima Centauri. To call Proxima B close is to misunderstand the scale of the universe. For us, it is still unimaginably far. This illusion of nearness fuels both hope and fear. Hope, because people imagine that if it is near, then perhaps it is reachable. Fear, because if even our nearest neighbor is unreachable with current technology, what does that say about the rest of the galaxy? Scientists caution that we must not let the nearness of Proxima B blind us to the staggering challenges of actually going there. The danger is that the term close lures us into thinking salvation lies just beyond our doorstep, when in reality, it lies across a gulf of time and distance almost impossible to bridge. If Proxima B has retained any atmosphere, its climate would likely be unlike anything on Earth. Simulations suggest that powerful winds would sweep endlessly across its surface, driven by the extreme contrast between its day and night sides. These winds could create violent storms of unimaginable force, tearing across the twilight band that might otherwise offer the best hope for habitability. But the climate dangers do not stop there. The red light of Proxima Centauri alters the way energy interacts with the planet. Photosynthesis as we know it might be impossible under such dim light, meaning that any attempt to grow Earth-based plants could fail. Even if crops were engineered to survive, constant flares from the star could sterilize them in moments. Water, if it exists on the surface, would circulate in bizarre and unstable patterns. Oceans on the day side might boil, while night side ice caps lock vast reserves of water away forever. This would create constant cycles of evaporation and freezing, generating climates no human farmer could ever predict or endure. Scientists fear that the climate of Proxima B would not just be hostile, but unstable, an ever-shifting machine of extremes. For humans, it would mean a fight not only against the environment, but against unpredictability itself. Colonizing Proxima B would not only be a scientific challenge, it would be a financial and societal one. The resources required to send a mission across interstellar space would dwarf anything humanity has ever attempted. Trillions of dollars, decades of planning, and the combined effort of nations would be needed. The fear is that such an effort could bankrupt or destabilize societies on Earth. In chasing the dream of Proxima B, we might divert resources away from solving urgent problems at home. Clean energy, climate adaptation, poverty reduction, all could be neglected in the pursuit of a gamble that may never succeed. Even worse, colonization could become the privilege of the few. If only the wealthy or powerful are able to secure places on generation ships, Proxima B could become a new frontier of inequality, an off-world refuge for elites, while the rest of humanity remains behind on a struggling Earth. Scientists and ethicists alike warn that Proxima B raises a dangerous question: who gets to decide humanity's future? The fear is not only that the planet may be uninhabitable, but that in the struggle to reach it, humanity may divide itself in ways that ensure only a fraction survives. One of the reasons Proxima B fascinates us so deeply is because it feels like a stepping stone toward answering the question of whether we are alone. If life could exist there, just for light years away, it would suggest the universe is brimming with it. And yet, the silence surrounding Proxima B is unsettling. For years, radio telescopes have scanned the skies around Proxima Centauri. Once, a mysterious signal was detected, narrow, precise, and seemingly artificial. For a brief moment, hope soared. Could this be evidence of intelligent life? But further analysis revealed it to be interference, another false alarm in the long search for extraterrestrials. This silence haunts scientists. If Proxima B were truly habitable, why does it not speak to us? Where are the civilizations that might have arisen under its red skies? The fear is that its silence is not accidental, but inevitable. Perhaps Proxima B shows us why life in the galaxy is so rare. Most habitable worlds are, in fact, traps, places that lure hope, only to extinguish it. If this is true, then Proxima B is not just another planet. It is a warning. The silence of its skies may be telling us that the path to survival among the stars is narrower, lonelier, and more dangerous than we dare imagine. Even if Proxima B is barren, there is another fear: what if we contaminate it? History shows that when humans explore, we bring more than curiosity, we bring bacteria, spores, and entire ecosystems hidden within us. On Earth, invasive species have reshaped entire continents. Imagine what might happen if Earth's organisms were unleashed upon Proxima B. If native microbes exist there, Earth's biology could overwhelm them in a matter of years, erasing billions of years of independent evolution. If no life exists, our bacteria could still thrive in unintended ways, mutating under alien radiation into forms we cannot control. Colonists might find themselves fighting not Proxima B itself, but new diseases of their own accidental creation. Scientists fear that contamination would not only destroy Proxima B's potential for study but also create unforeseen dangers. Introducing Earth life to an alien world is not like planting crops in new soil, it is rewriting an entire biosphere with unknown consequences. To make Proxima B habitable, we may first have to sterilize it of whatever life, or potential for life, it already has. And in doing so, we risk destroying one of the greatest scientific discoveries in human history. When we look at Proxima B, we see a planet in the present. But in reality, we are looking at the product of billions of years of cosmic evolution. Planets change over time, they freeze, boil, erode, and decay. Earth itself has undergone cataclysmic shifts, from snowball states to greenhouse worlds. What we see as stable is, in truth, a fragile balance in constant motion. Proxima B may once have been more Earth-like. Perhaps it had oceans, clouds, and fertile land. But under the relentless fury of Proxima Centauri, it may have lost them all. It could be that we are seeing the end of a world, not the beginning of one. This raises a chilling possibility that Proxima B is not just dangerous, it is doomed. Even if humanity invested centuries into terraforming, cosmic time may undo it all. Over millions of years, stellar flares could strip its atmosphere faster than we could replace it. Over billions, even the star itself will change, growing brighter and more unstable. Scientists fear that colonizing Proxima B might be like building a city on a coastline doomed to vanish beneath the sea. It may serve for a moment, but in the long march of time, it cannot last. And if Proxima B itself cannot last, then it reminds us that permanence may be an illusion, not only for alien worlds, but for our own. To even attempt reaching Proxima B, humanity would likely need to build generational ships, massive vessels where entire communities live and die during the journey. These ships would not just carry passengers, they would carry civilizations, complete with food systems, waste recycling, and cultural traditions. 1,000 years could pass before the first human ever set foot on the planet. The fear is that such ships could fail long before arrival. Ecosystems aboard might collapse, machinery could corrode, or societal fractures might tear apart fragile communities. Children born in transit would know no other home, raised to continue a mission they never chose. For them, Proxima B would be more myth than reality, a promise passed down like folklore. Scientists fear that the very concept of generational voyages might doom us psychologically. Could humans sustain purpose over centuries of darkness, confined to steel walls, with no promise of success? History shows that even short isolation, on submarines or Antarctic bases, pushes the human mind to its limits. Now imagine that isolation stretched across lifetimes. The risk is that Proxima B might never be reached at all. Instead, humanity could create ghost ships adrift between the stars, filled with descendants who no longer remember their mission, lost in the eternal void. Every vision of Proxima B assumes flawless technology, starships crossing light years, habitats protecting settlers from radiation, terraforming machines sculpting alien skies. Yet history reminds us that technology is fragile. It breaks, decays, and fails in ways we cannot always predict. On Earth, when machines fail, we can repair them with supply chains and global infrastructure. On Proxima B, colonists would be utterly alone. A single malfunction in life support systems could doom thousands. Radiation could fry circuits, alien dust could clog machinery, and resources needed for repair might not exist on the planet at all. Even the journey there could unravel through technological failure. Engines may falter mid-voyage, cryogenic chambers may crack, navigation systems may miscalculate. A single error could transform the mission into a drifting tomb. Scientists fear that Proxima B's greatest barrier is not its environment, but our reliance on fragile technology. To survive there would require machines that never fail, systems that never collapse, and tools that never decay. And in the history of humanity, such perfection has never existed. Perhaps the most chilling fear surrounding Proxima B is not that it is barren, but that it is alive. If the planet harbors even primitive microbial life, humanity faces a dilemma unlike any before. Contact with alien biology could be catastrophic for both sides. Earth organisms could invade Proxima B's biosphere, overwhelming it. Proxima microbes, shaped by millions of years of alien evolution, could be deadly to humans. Even if they were harmless, their chemistry might interfere with our crops, our machines, or even our very DNA. And then there is the possibility, however remote, of something more advanced. Intelligent life, even in its earliest stages, would raise questions of ownership, morality, and survival. Do we have the right to colonize a world already claimed by others? What if they view us not as explorers, but as invaders? Scientists fear that Proxima B may not just challenge us scientifically, but ethically. To step onto its surface might mean sparking the first contact in human history. And in that moment, we may learn that the galaxy is not empty, and that our arrival is not welcome. If humanity ever settled on Proxima B, the colony would be utterly dependent, at least in its early years, on supplies from Earth. Food, medicine, spare parts, and advanced technology would need to be shipped across light years. Yet with a 4-year delay in even the fastest communications, such a supply chain would be unsustainable. Imagine a crisis in a colony dome, an oxygen generator fails, or a disease spreads. On Earth, a solution might take weeks. On Proxima B, even a desperate request for help would take 8 years to yield an answer, for the plea to reach Earth, for the reply to return. By then, the colony could be gone. Scientists fear that dependence itself may doom any early settlement. Colonists would need to be completely self-sufficient from the start, a goal almost impossible with our current knowledge. Every seed, every circuit, every vial of medicine would need backups. Every tool would need redundancy. Yet the universe has a way of presenting problems no one anticipates. A single oversight could cascade into catastrophe. Proxima B does not forgive mistakes. And for a dependent colony, the smallest error could mean extinction. Earth's ecosystems depend on a delicate chemical balance. The oxygen we breathe, the water we drink, even the soil that nourishes plants, all are products of billions of years of coevolution. On Proxima B, those balances might not exist. Its rocks, air, and water may be composed of unfamiliar chemicals that react unpredictably with human biology and technology. For settlers, this means risk in every breath and every bite. Water drawn from alien wells might contain compounds toxic to human organs. Soil may resist Earth crops, poisoned by minerals that disrupt growth. Even the air, if breathable at all, could carry subtle dangers, corroding lungs over time or destabilizing immune systems. Technology, too, might falter. Metals may corrode differently, lubricants may freeze or evaporate in unexpected ways, and machinery designed for Earth conditions could fail in alien chemistry. Scientists fear that the very building blocks of survival, food, water, shelter, may betray us. Even if Proxima B appears solid, its chemistry may be quietly hostile, turning every attempt to live there into a battle against invisible, alien poisons. Every discussion of Proxima B carries an unspoken consequence. What would it mean to leave Earth behind? If colonization succeeded, it might create a second home for humanity. But if it failed, or even if it succeeded for only a few, the legacy would be abandonment. Generations of people might grow up on Earth knowing their leaders invested more in an alien world than in saving their own. For those left behind, Proxima B could become a bitter symbol, not of hope, but of betrayal. And for the colonists themselves, the guilt of leaving Earth behind might weigh heavily, knowing that while they survived under alien skies, billions perished under a dying sun. Scientists and ethicists fear that Proxima B could split humanity not only physically, but philosophically. It forces us to ask, do we fight for Earth until the very end, or do we scatter into the cosmos, leaving our birthplace to fade? In chasing the dream of Proxima B, we may not only risk our survival. We may risk our unity, our legacy, and the meaning of what it is to be human. Humanity's survival is not built only on technology or biology, but on spirit. History shows that societies collapse not only from external threats but from within, when morale breaks, when hope fades, when unity fractures. On Proxima B, morale could be the most fragile element of all. Life under alien skies would mean constant danger, endless confinement, and the knowledge that Earth was out of reach. Colonists would wake every day under a blood-red sky, knowing they could never leave. Food would be rationed, sunlight dim, and every mistake a potential death sentence. Over time, the weight of monotony and fear could corrode even the strongest minds. Mutiny, despair, and division would be real threats. A single breakdown in trust could unravel an entire settlement. Unlike Earth, there would be no new supplies, no reinforcements, no fresh start. Once morale collapses, survival collapses with it. Scientists fear that Proxima B would not kill humanity with radiation or storms, but with something far quieter, the slow erosion of human will. The colony might not fall in fire and catastrophe, but in silence, when the last survivors simply stop fighting to endure. Colonizing Proxima B would demand unimaginable leaps in technology, advanced propulsion, artificial ecosystems, closed-loop recycling, radiation shielding, and more. But once settlers arrived, they might face a paradox. In order to survive, every resource would need to be devoted to maintenance, not innovation. Unlike Earth, with its billions of mines and global networks, a colony would have only a small, isolated population. Their priority would be keeping life support systems running, not advancing science. Progress could stagnate, or even reverse. Generations might grow up knowing only how to preserve what they have, without ever learning how to build something new. This raises a chilling possibility. Humanity might send its brightest technologies to Proxima B, only for them to wither in isolation. Colonists could regress, locked into survival mode, losing knowledge over time. After centuries, the colony might not be a beacon of the future, but a fragile remnant of a past civilization, cut off, stagnant, and vulnerable. Scientists fear that Proxima B might not represent humanity's next step forward, but a step backward, a trap that consumes progress instead of extending it. Perhaps the greatest fear of all is that once humanity commits to Proxima B, there is no turning back. A journey across light years is not like crossing oceans. There will be no rescue missions, no resupply convoys, no second chances. Once launched, the mission is final. Success or failure will define generations. This irreversibility weighs heavily on scientific minds. Every variable, radiation, geology, atmosphere, climate, is uncertain. A single miscalculation could doom the project forever. Yet once the engines ignite and the ships depart, humanity would be committed, unable to recall them. The decision to colonize Proxima B would therefore be the most consequential in human history. It would not only determine the fate of the colonists but reshape the destiny of our species. If it fails, humanity may never recover the will or resources to try again. Scientists fear that the allure of Proxima B tempts us into rushing such a decision before we are ready. And in the vast silence of space, there are no second chances. Proxima B is not the first planet we have imagined as a home. Mars, Venus, and even our own moon have long tempted us with visions of settlement. Yet each time, deeper study reveals harsh truths. Mars is frozen and irradiated, its thin atmosphere offering little protection. Venus is a furnace, its skies filled with sulfuric acid. The moon is airless, silent, and barren. In each case, optimism gave way to sobering reality. And Proxima B may be no different. Scientists fear that we are repeating the same cycle on a grander scale, projecting dreams onto a world we do not fully understand, only to discover later that it is far more hostile than imagined. The ghosts of these worlds linger in every discussion of Proxima B. They remind us that the universe is not generous with habitability. Earth is not normal, it is extraordinary. And if even nearby planets in our own solar system proved so inhospitable, what chance does a distant exoplanet really hold? The fear is that Proxima B may join this gallery of false hopes, a place we dream of, only to realize it was never meant for us. Colonizing Proxima B would not be a matter of exploration alone, it would be a matter of economics. The materials required for interstellar travel, life support domes, radiation shielding, and terraforming would be astronomical. To fund such a project, Earth would need to redirect vast portions of its wealth, technology, and labor toward a single goal. But who would bear the cost? Would entire nations be bankrupted for the sake of a distant gamble? Would the poorest be left behind while the wealthy secure their passage to another world? These questions strike at the heart of global inequality. Scientists and ethicists fear that the attempt to reach Proxima B could accelerate division on Earth. It could pit nations against one another, fuel competition for resources, and create new geopolitical tensions. And if the project failed, the cost would be borne not only in treasure, but in trust. Humanity might fracture under the weight of its own ambition. In this way, Proxima B is not just a scientific challenge, but a social one. To reach it might demand sacrifices Earth is not prepared to make. At the core of humanity's fascination with Proxima B lies a deeper question: is it our destiny to spread beyond Earth? For some, the answer is obvious. The stars are our inheritance, and Proxima B is the first step. But for others, the fear is that this dream blinds us to reality. If Proxima B is uninhabitable, or if colonization leads only to failure, what does that say about humanity's future? Are we meant to remain confined to Earth, prisoners of our own fragile biosphere? Or is our desire to escape nothing more than hubris, a refusal to accept the boundaries nature has placed upon us? Scientists warn that Proxima B forces us to confront this uncomfortable dilemma. If we chase it and fail, we may discover that humanity's destiny is not among the stars, but within the narrow cradle of Earth. That realization could be crushing, not only scientifically, but spiritually. For in Proxima B, we see both hope and fear. It offers the vision of a future beyond Earth, but also the haunting possibility that the universe may never welcome us. On Earth, life thrives through complexity. Forests, oceans, and plains are networks of species interwoven in delicate balance. Every insect, plant, and predator plays a role in sustaining the whole. Yet on Proxima B, such balance does not exist. If humans attempted colonization, we would need to carry entire ecosystems across interstellar space, soil microbes, pollinators, crops, and animals compressed into artificial habitats. The challenge is that ecosystems are not machines that can be switched on and off. They are dynamic, fragile, and unpredictable. On Earth, when a single species disappears, entire chains can collapse. On Proxima B, even the smallest failure, a pollinator unable to adapt, a fungus unable to thrive, a plant unable to grow, could unravel an entire agricultural system. Scientists fear that settlers would find themselves constantly fighting collapse. Crops could fail under alien light, livestock could weaken under higher gravity, and soil ecosystems might never stabilize. A single imbalance could trigger famine. And unlike Earth, where ecosystems recover over centuries, a colony on Proxima B would not have the luxury of time. Thus, Proxima B may not only be inhospitable, it may reject life itself, resisting every attempt to seed its barren surface with Earth's fragile web. Proxima B's slightly higher gravity, perhaps 1.3 times that of Earth's, might sound negligible, but over time it could shape everything. Settlers would feel its weight in their muscles and bones, in the effort of every step. Tools would wear faster, structures would bear greater stress, and agriculture would require adaptations to keep plants from collapsing under their own weight. For human biology, the strain could be profound. Heart rates would rise, circulation would struggle, and injuries would take greater tolls. Over generations, colonists might adapt, becoming shorter and stronger, their physiology altered by the invisible hand of gravity. But this adaptation would come at a cost. Returning to Earth might become impossible, their bodies unable to adjust back to lighter conditions. Scientists fear that colonization of Proxima B could create irreversible change. Settlers might never again be able to leave, trapped not by walls or distance, but by their own biology. In choosing Proxima B, humanity may not be creating a new home, but a new prison, one in which every generation grows further apart from the Earth that birthed them. What makes Proxima B so frightening is not only what we know, but what we do not. Each model, each simulation, each telescope reading offers only fragments of truth. We cannot yet see its surface, cannot yet confirm its air, cannot yet measure its seas or rocks. And in that absence, imagination runs wild. For some, this uncertainty is hope. Perhaps Proxima B is lush with oceans and clouds, waiting for explorers. But for scientists, uncertainty is risk. Every unknown variable could hide disaster. Perhaps its surface is a radioactive wasteland. Perhaps its atmosphere is toxic. Perhaps it is geologically unstable, tearing itself apart with quakes and eruptions. The fear is that we will not know until it is too late, until ships have launched, until colonists have committed, until the point of no return has passed. Humanity would be gambling not with money or technology, but with lives. And in the silence of the cosmos, there are no second chances. Thus, Proxima B stands as a riddle cloaked in uncertainty. It tempts us with possibility, but shadows every step with fear. Humanity prides itself on resilience. We have survived ice ages, plagues, wars, and disasters. We have crossed oceans, built cities in deserts, and thrived on mountaintops. Yet Proxima B would test us in ways no environment on Earth ever has. Every aspect of life there would be survival under pressure. Radiation poisoning would be a daily threat. Food and water would require constant management. Breathing itself might depend on fragile machines that can never fail. The settlers would not have the luxury of nature's abundance. Every breath, every sip, every bite would be engineered, measured, rationed. Scientists fear that human resilience has limits. Stress would not only erode bodies, but minds. Generations raised under alien skies, never knowing Earth, might see resilience not as strength but as chains. What begins as determination could turn into despair, resentment, and collapse. Resilience may have carried humanity across history, but Proxima B would ask for something beyond resilience. It would demand sacrifice without end, and the question is whether humanity is truly capable of such unyielding endurance. Though Proxima B is only 4 light-years away, human imagination often invokes dreams of faster-than-light travel, warp drives, or cryogenic sleep to make the journey possible. These ideas fill science fiction with optimism. But in reality, the laws of physics remain unbroken, and the dream of effortless travel remains just that, a dream. This gap between imagination and reality is itself a danger. The public hears of Proxima B and assumes technology will inevitably rise to meet the challenge. But scientists know there is no guarantee. We may never overcome the barriers of physics that bind us. The fear is that Proxima B seduces us into believing in technologies that may never exist. If we pin our hopes on time dilation, warp engines, or suspended animation, we risk building our future on fantasy instead of fact. And when the fantasy fails, humanity may be left stranded, dreaming of stars we cannot reach. Proxima B is not only a planet. It is a test of humility. It reminds us that the universe does not yield its secrets easily, and that time itself may stand as our greatest enemy. Colonizing Proxima B would not be like exploring Antarctica or the Moon. Once humanity commits, there would be no retreat. A generation ship launched cannot turn back. A settlement built cannot easily be abandoned. The choice would be final. This irreversibility terrifies scientists. Every variable must be weighed, every risk accounted for, every contingency prepared. And yet, uncertainty makes perfection impossible. Somewhere, hidden in the unknown, there will be a flaw, small or large, that escapes calculation. The fear is not simply of failure, but of entrapment. Colonists may survive, but barely, enduring centuries in fragile domes, never truly thriving, never truly free. The dream of a new Earth may instead become the reality of a gilded cage, where survival is possible, but life as we know it is lost. Proxima B demands a choice humanity cannot undo. And that choice may define our species forever, not by what we gain, but by what we sacrifice in pursuit of the stars. On Earth, memory is preserved through history, archives, and culture passed down through generations. But on a generational voyage to Proxima B, or in a colony isolated under alien skies, memory itself could fracture. Languages drift, traditions mutate, and records are lost. Over centuries, the story of why settlers left Earth might fade into myth. Children born in the colony might never understand Earth as a real place. Its oceans, mountains, and blue skies would sound like legends of a paradise lost. Over time, resentment could grow. Why cling to myths of a planet for light years away, unreachable and irrelevant? Why preserve traditions from a world that abandoned them? Scientists fear this cultural drift could sever colonists from their heritage. Earth may remain the cradle of humanity, but for Proxima B settlers, it may become nothing more than an echo. And in that silence, identity could warp into something unrecognizable. Memory, once fractured, cannot be mended. Colonizing Proxima B may not only reshape our biology, but our very sense of who we are. On Earth, when civilizations collapse, there are always survivors. Empires fall, but humanity endures in other corners. Knowledge may be lost, but seeds remain to rebuild. On Proxima B, collapse would be total. An isolated colony would have no neighbors to send aid, no allies to preserve knowledge, no outsiders to carry forward its story. A Proxima B settlement could vanish completely, its technology corroded, its habitats buried under dust, its people gone. Centuries later, even Earth might not know what became of them. A message sent as they perished would take for years to arrive, perhaps too late to act. Scientists fear this possibility most of all, failure in silence. Colonization could end not in dramatic collapse, but in quiet extinction, unobserved and unmourned. A people forgotten, their voices lost between the stars. For Earth, the tragedy would not only be the loss of life, but the loss of knowledge. Humanity would never know why the attempt failed, only that it did. And that uncertainty could haunt us for centuries, discouraging every future step toward the stars. Perhaps the most unsettling fear is that Proxima B is not a promise of what we could gain, but a mirror of what we could lose. Its barren landscapes, if barren they are, remind us that habitability is not the rule, but the exception. Its hostile star, its volatile climate, its stripped atmosphere all reflect a truth: Earth's balance is fragile, and even small changes can transform paradise into wasteland. Scientists look at Proxima B and see not a second home, but a vision of Earth's possible future. If our planet loses its atmosphere, if its climate spirals into chaos, if its biosphere collapses, Earth too could become another Proxima B, a world where life was possible, but no longer is. This mirror terrifies researchers. Proxima B is not just a distant planet, it is a warning. In its silence, it tells us life is rare, balance is fragile, and survival is never guaranteed. To ignore this warning is to risk making our own world just as inhospitable. Terraforming has long been imagined as the solution to inhospitable worlds. Science fiction envisions machines that reshape atmospheres, warm frozen planets, and conjure oceans from barren rock. But the reality of terraforming Proxima B would be far more fragile. Every step would risk catastrophe. Releasing gases to warm the surface could spiral into a runaway greenhouse effect, boiling away water and choking settlers. Thickening the air to protect against radiation could trap heat in unpredictable ways, creating violent storms. Even small miscalculations in atmospheric chemistry could make the planet toxic. On Earth, nature regulates itself. Rainforests absorb carbon, oceans store heat, and life itself shapes climate. But on Proxima B, no such regulators exist. Every adjustment would need to be engineered, and every mistake could prove fatal. Scientists fear that even if humanity managed to begin terraforming, Proxima B would resist stability. Like a pendulum swinging between extremes, the planet could shift unpredictably, forever out of balance. In trying to make it habitable, we might only make it more hostile, turning Proxima B into a vast, unstable experiment with no way to undo the damage. Colonization of Proxima B would not be achieved by one generation, or even two. It would demand sacrifices across centuries. Those who begin the journey would never see its end. Those who land might never see it become livable. And those who labor to terraform might never know whether their descendants succeed. This raises profound ethical questions. Can we ask entire generations to sacrifice their lives for a dream they will never enjoy? Can children born aboard ships, or in alien colonies, be bound to a mission they never chose? Scientists fear that this generational burden could fracture the very will of the colony. Some may refuse the mission, choosing instead to build their lives in defiance of a destiny imposed upon them. Others may lose faith in the dream of habitability, resigning themselves to survival rather than transformation. The danger is not simply technological, it is generational despair. Proxima B might demand not just courage, but centuries of endurance. And humanity has never before attempted a sacrifice so vast. Perhaps the most haunting fear of all is the realization that the universe is indifferent to our struggles. Earth feels uniquely suited for life, yet that suitability is an accident of cosmic history. Proxima B reminds us that the cosmos is not shaped for us, it simply is. Its storms, radiation, and barren landscapes are not malicious, but they are merciless. They do not care for our dreams of colonization or survival. They simply exist. And against that indifference, humanity may find itself powerless. Scientists look at Proxima B and see a truth that unsettles them: the universe is not waiting to welcome us. It is not filled with second Earths waiting to be claimed. It is vast, hostile, and silent. And the very fact that Proxima B, the closest exoplanet, appears so dangerous may be proof of this. To attempt to make Proxima B habitable is to pit human will against cosmic indifference. And the fear is that no matter how hard we try, the universe may not bend. It may remind us, again and again, that survival is not promised, not even for us. If Proxima B is tidally locked, the twilight zone, the narrow band between eternal day and endless night, may be the only region capable of sustaining liquid water and tolerable temperatures. But living in such a band would mean confinement beyond imagination. Imagine a civilization trapped along a narrow strip of land, stretching around the planet like a scar. On one side, scorched deserts; on the other, frozen wastelands. To step too far in either direction would mean death. Colonists would be forced to build cities and farms along this fragile frontier, clinging to the razor's edge of habitability. But the twilight zone may not be stable. Winds from the day side could howl across it, carrying radiation storms. Ice from the night side could creep into it, choking fertile ground. And as climates shift, the habitable strip might shrink or vanish entirely. Scientists fear that humanity could find itself imprisoned on Proxima B, not on a planet, but on a ribbon. A fragile, precarious band of survival, narrower than the hope that sent us there. On Earth, when we make mistakes, the planet often forgives us. Crops fail, but new ones can be planted. Ecosystems collapse, but nature finds ways to heal. Even disasters like oil spills or nuclear accidents, while devastating, eventually fade under Earth's resilience. On Proxima B, there will be no such forgiveness. Every mistake could be permanent. A single miscalculated atmospheric adjustment might poison the air forever. A nuclear accident in a colony dome could render entire regions unlivable. A failed agricultural system could wipe out generations of settlers with no way to recover. The lack of safety nets terrifies scientists. There will be no backup planet, no second chance. Every decision must be perfect, every calculation precise, every system flawless. But perfection is a standard humanity has never achieved. Proxima B demands error-free survival in a universe where errors are inevitable. And in that paradox lies perhaps the greatest fear, that no matter how carefully we prepare, one mistake will doom it all. For all its dangers, Proxima B still captures the human imagination. It is the closest exoplanet, the nearest chance at a new world. That very closeness ignites hope, a fragile fire that burns against the darkness of space. But hope can be dangerous. If humanity invests centuries of work, trillions of dollars, and untold sacrifices into Proxima B, that hope could become obsession. We may pour everything into the dream of habitability, only to find it was never possible. When hope collapses, it collapses hard. And the backlash could be devastating, leaving humanity not inspired, but broken. Scientists fear not just failure, but the collapse of hope itself. If Proxima B betrays us, will humanity ever dream again of the stars? Or will we turn inward, defeated, our ambitions crippled by the weight of one shattered vision? In this sense, Proxima B holds our greatest dream and our greatest fear. It is a beacon that could lead us forward, or blind us forever. On Proxima B, survival would likely depend on building sealed habitats, domes, underground cities, or orbiting stations. These artificial worlds would be humanity's only shield against radiation, thin air, and hostile climates. But artificial worlds are fragile. Every dome would need to remain perfectly sealed for centuries. A single crack in the glass, a breach in a wall, a failure in a filtration system could kill thousands. Unlike Earth, where the open sky always provides air and space to escape, Proxima B would offer no margin of error. A broken door could mean suffocation. A failed generator could mean freezing. Scientists fear that life on Proxima B would not feel like living on a planet at all, but like living inside a prison of machines. Every moment would depend on human engineering holding back the chaos outside. And over centuries, the fragility of those machines could become the fragility of humanity itself. On Earth, when disasters strike, survivors cry out and others come to their aid. But on Proxima B, failure would happen in silence. If a colony collapsed, no rescue ship could arrive. No relief convoys would cross the Gulf. Their voices would travel for years, arriving only after they were gone. This silence weighs heavily on scientists. To fail on Proxima B is not only to perish. It is to perish unheard. Families on Earth would wait years for signals that never come. By the time they learned of disaster, the tragedy would already be ancient history. The fear is that Proxima B magnifies failure into finality. There is no rescue, no second chance, no one to bear witness. The colonists' last breaths would fade into the void, swallowed by the same silence that cloaks the stars. When scientists study Proxima B, they cannot help but compare it to Earth. Every difference, its dim red sun, its flaring storms, its uncertain atmosphere, reminds us how rare our own world truly is. On Earth, we breathe freely, drink from rivers, grow food in soil, and stand under a protective sky. On Proxima B, none of this would be possible without immense effort. This comparison fills scientists with unease. If humanity spends so much energy trying to build an Earth on Proxima B, why not spend the same energy preserving the Earth we already have? The fear is that Proxima B distracts us from the real challenge, saving our own planet before it too becomes uninhabitable. In this way, Proxima B is not only a scientific puzzle, it is a moral one. It forces us to ask whether we are running toward the stars out of ambition, or running away from the responsibilities of home. And the fear is that in choosing the latter, we doom ourselves twice, once on Earth, and once among the stars. For a colony on Proxima B, communication with Earth would always be delayed. A single message would take more than 4 years to arrive, and another 4 for the reply to return. For settlers, conversations with loved ones on Earth would not be dialogues, but echoes across time. This delay creates profound risks. Emergencies could not be solved together. Political disputes between Earth and the colony could take decades to resolve, each side acting in the dark. Misunderstandings might spiral into mistrust, and mistrust into conflict. Scientists fear that communication delays would isolate Proxima B far more than distance alone. Colonists might grow resentful, cut off from real-time connection, forced to make decisions without support. Earth, in turn, might feel powerless, unable to guide or aid. In this silence, the bond between home and colony could erode until it vanishes entirely. What began as humanity's greatest link to the stars might end in estrangement, with Proxima B no longer a child of Earth, but a stranger. Every colony requires resources, metals for tools, fuel for energy, minerals for construction. On Earth, these come from vast networks of trade and industry. But on Proxima B, colonists would rely only on what they could carry or mine locally. And no one knows whether Proxima B even possesses the resources settlers would need. If metals are scarce, technology could stagnate. If fuel sources are absent, energy could collapse. Even if resources exist, they might be buried deep, locked behind alien geology too difficult to access. The dream of a thriving colony could quickly become a struggle for scraps. Scientists fear that resource scarcity could doom any settlement to poverty and fragility. Colonists might survive, but they would never prosper. They would live on the edge of collapse, every tool worn thin, every structure patched together, every failure one broken component away from catastrophe. Proxima B could become not a new frontier of abundance, but a place of permanent scarcity, an exile world where humanity survives, but never truly lives. In the end, what makes Proxima B so terrifying is not only its dangers, but what it reveals about the cosmos. For centuries, we imagined the galaxy filled with Earth-like worlds, waiting for us. But the closer we look, the more we realize how rare Earth truly is. Proxima B, our closest neighbor, is not a paradise. It is a gauntlet of radiation, storms, and uncertainty. If even the nearest world is so hostile, what hope is there that the galaxy holds countless havens for us? Perhaps life is not common, but rare. Perhaps Earth is not one of many, but one of few. Scientists fear that Proxima B forces us to confront this possibility. That habitability is not the rule, but the exception. That Earth may be our only true home in a galaxy indifferent to our survival. And if that is true, then the greatest danger of Proxima B is not that we might fail to make it habitable. It is that, in trying, we may finally understand how alone we truly are. On Proxima B, food would be humanity's most fragile lifeline. Without fertile Earth-like soil, colonists would depend on hydroponic farms, genetically engineered crops, and tightly controlled ecosystems. Every calorie would be cultivated under artificial lights, powered by fragile energy systems that could never fail. But agriculture is not simple. Plants require more than light and water, they depend on pollinators, microbial interactions, and balanced chemistry. On Proxima B, each of these would need to be replicated by machines or carefully transplanted Earth systems. Even the red light of Proxima Centauri could disrupt photosynthesis, forcing crops to be re-engineered at enormous cost. Scientists fear that agriculture would become a constant battle. A failed crop cycle could trigger famine. A single blight could wipe out an entire colony's food supply. And unlike Earth, where diversity ensures resilience, Proxima B farms would be fragile monocultures, efficient, but vulnerable. Colonists might spend more energy keeping their food alive than keeping themselves alive. And in that endless struggle, the dream of prosperity could dissolve into the reality of survival by the thinnest thread. On Earth, when machines fail, we repair them easily. Replacement parts can be manufactured, engineers can be trained, and supply chains can deliver what is missing. On Proxima B, none of these luxuries would exist. Every machine, from life support systems to power generators, would need constant care. Replacement parts would need to be fabricated locally, often without the raw materials Earth industries rely on. Over decades, technology might degrade, patched together with whatever the colonists could salvage. This tyranny of maintenance could define life on Proxima B. Settlers would not be pioneers of new frontiers, but mechanics trapped in endless cycles of repair. Their survival would depend not on exploration or innovation, but on keeping ancient machines alive long past their intended lifespan. Scientists fear this slow decline more than sudden catastrophe. A colony might not collapse in one dramatic failure, but fade over centuries, its technology crumbling, its people reduced to subsistence. Proxima B could transform not into a second Earth, but into a long, slow regression, civilization unraveling under the weight of machines that no longer work. Perhaps the most haunting aspect of Proxima B is not its storms, its radiation, or its geology, but its darkness. Orbiting a red dwarf, its skies would never blaze with the brilliance of Earth's sun. Instead, they would glow dimly, cloaked in shades of crimson and twilight. This perpetual half-light would shape not only the environment, but the human psyche. Generations born under a red sun would never know blue skies or golden mornings. Shadows would dominate their world, casting an eternal gloom across the land. Psychologists fear the toll this would take. On Earth, lack of sunlight already leads to depression, disorientation, and illness. On Proxima B, such conditions could become universal, baked into the very fabric of daily life. Artificial lights could help, but they would be reminders of what has been lost, not replacements for what once was. In this endless twilight, colonists might find themselves not inspired by the stars, but crushed by the weight of alien skies. Proxima B would not only test bodies and machines, it would test souls. And the fear is that souls may not endure. As the pieces fall into place, a chilling picture emerges. Radiation storms tear at the skies. Tidal locking traps life in narrow ribbons of twilight. Atmospheres vanish, chemistry turns alien, and fragile machines groan under the weight of endless repair. Generations sacrifice themselves for a dream they will never see, while isolation shatters memory and hope. Scientists do not fear Proxima B simply because it is hostile. They fear it because it reflects back at us the fragility of our own existence. It reminds us that habitability is not common, but rare. That survival is not the rule of the cosmos, but the exception. And that humanity's belief in endless frontiers may itself be an illusion. In Proxima B, we see a mirror of Earth's possible future, a world stripped bare, its skies hostile, its waters gone. To chase Proxima B is to confront the possibility that this fate awaits us here as well. The warnings are clear: if we cannot preserve the balance of our own home, no star, no planet, no exoplanet will save us. Proxima B is not only a destination. It is a test, and perhaps a warning, that the universe may not be waiting for us at all. That the stars may be silent not because life is rare, but because survival itself is fleeting. And so, Proxima B stands at the edge of our imagination. It tempts us with closeness, with the illusion of a second Earth. Yet behind that illusion lies danger, silence, and indifference. Its hostile skies whisper a truth few dare to hear: not every world can be made habitable, not every frontier is meant for us. The scientists who study Proxima B do not dream only of possibility, they tremble at its warning. They see in its red twilight the cost of overreach, the danger of false hope, and the reminder that Earth is extraordinary beyond measure. The fear is not that Proxima B will reject us, but that in chasing it we will forget the lesson it teaches. That survival requires care, that life is fragile, and that Earth itself is our most precious, irreplaceable sanctuary. Perhaps one day we will reach Proxima B. Perhaps one day we will even survive there. But until then, its greatest gift is not as a home, but as a reminder: the universe is vast, but not welcoming. And if we wish to endure, we must always protect the only true haven we have ever known: the Earth.